this problem from the concept of tangent normal, differential equation and conic section. Three topics together. The normal to a curve at P meet the x-axis at G. If the distance of G from the origin is twice the abscissa of P, then the curve is. Okay. So we first write down the equation of normal to any curve at the point P. Okay. And clearly the equation of normal is given by y minus y. This is equal to minus dx dy into x minus x. Okay, this is the equation of normal. Now this normal meet the x-axis at G and meet x-axis at G. So we put y, this is equal to 0. This is not small y, this is capital Y. We put this is equal to 0 to find out the intersection with x-axis. That is to find out the coordinate of G. Okay. So we put y equal to 0 here and getting the value x minus x. This is minus dy dx into 0 minus y. Okay. This is by putting y equal to 0 here and we write dy dx in the left side. And this gives x equal to, this is y dy dx plus x. Okay. And clearly y this is equal to 0. So the distance of xy from the origin is given by, it is d, this is given by x minus 0 whole square plus y minus 0 whole square. And here x is this and y is 0, so it is 0. If we put x, this is equal to, so we get the value of x, this is y dy dx plus x. This is the distance d from the origin to the point G. Okay. Now it is given that this distance is equal to twice the abscissa of P. What is the abscissa of P? For the point P, x, y, x is the abscissa and y is the ordinate. Okay. So from the given condition, we must write y dy dx plus x. This is equal to 2x. This is the twice ordinate. It is given here. So we get y dy. This is 2x minus x into dx. Now integrating, we get y square by 2. This is x square by 2. And we let the integrating constant, this is square by 2. So we get y square minus x square, this is equal to c square. And this is clearly rectangular hyperbola or equilateral hyperbola. In our option, it is given that the curve are parabola, curve is parabola, circle, hyperbola and ellipse. So our correct option is hyperbola. There is no option to marking rectangular hyperbola or equilateral hyperbola. So our correct option is option number 3. Very, very important problem from differential equation. Okay, thank you for watching.